Hello students, today we are going to study about capacitance and capacitors. What are capacitors and what is capacitance? Capacity is something to store. Now what are we storing in electrostatics? We are going to store charges. Okay, now we need to store charges. The device which stores charges is a capacitor, and the ability is called capacitance. Now what a capacitor consists of? How can we make a capacitor? Very simple. We need two parallel plates. Okay, I am going to take two plates, metallic plates, two parallel plates. Now I am going to connect this to a battery or a cell. Potential difference. You see, I have connected two parallel plates. Let us say plate A and plate B, and I am connecting this plate to a cell. The cell will provide a potential of V. Fine. So let me complete the circuit. Fine. Now what will happen? Basically, there are electrons in the cell. The electrons will start moving through the connecting wire. Electrons are negative, electrons will flow from negative terminal and it will move through the connecting wire and it will go and deposit itself on the plate B. See, the electrons are getting deposited on the plate B, and there is a gap here. Now the electrons cannot jump, nothing can happen. But according to law of conservation of charge, the electron which is gone, the electron has to come back. Now from where the electrons will come? The electrons will come from plate A. When electron is removed, this will become positive, this will become positive, and the electrons move from plate A and it comes back to the battery or the cell. So the electron has moved from the negative terminal and it comes back to the positive terminal. So what has happened is the circuit is closed circuit. Now by connecting a potential difference of V, I have put a charge on the plates, and let us say the charge on the plates is Q. On this it is minus Q, on this it is plus Q. Fine. So we have stored electric charges in these two plates by connecting the external cell or a battery. So we define capacitance as the charge stored in the plates divided by. How are we able to store these charges? By applying a potential difference V. So capacitance C is equal to Q upon V. This is the formula. Now what is Q? Charge. Charge is measured in coulomb, and V is potential difference, which is in volt. So C volt per. So this is the unit of capacitance. But coulomb per volt, it is better to write it with another unit that is called farad. Farad comes from Michael Faraday, right? Faraday is not the unit, farad is the unit of capacitance. But 1 farad is a very big unit, so we use microfarad and picofarad. Now what is micro? Micro stands for 10 power minus 6 farad. And what is picofarad? 10 power minus 12 farad. Keep this in mind. It's very important that we often use picofarad. And as far as charges are concerned, we use coulomb, microcoulomb, right? So these are the smaller units because farad is a very big unit. Fine. Now with this concept in us, we are going to learn about more about capacitors, right? Let us now see if I connect the capacitors in series, what will happen? If I connect them in parallel, what will happen? Let me do a simple exercise here with you. Connecting capacitors in series, right? This is just like resistors, that is in current electricity. Here we are going to talk about capacitors in series. Let us take three capacitors. One, fine. Let us take three capacitors. C1, C2, C3. These three capacitors are connected one after the other, and so they are in series. You know that plus Q1 is the charge on it, plus Q2 is the charge on it, and plus Q1. See, in series, just like in the case of current is same in series in resistance, the charge will be same, plus Q and minus Q. Fine, plus Q and minus Q. Charge remains the same, conservation of charge. Okay, and what is going to differ? Let us take the point to be A and let this point to be B. It is connected across the potential difference of capital V. So across this C1 it is V1, and this is V2, and this is V3. Okay, so this is V3. So let us draw it like this. So the potential across each capacitor is V1 and then V2 and V3. Capacitors are C1, C2 and C3. Charges Q, Q, Q. Q remains same. You have to keep one thing in mind. We define capacitance is equal to Q upon V. Now C is changing, different capacitance and potential difference is different, then one of this has to remain constant. All of them cannot change. Here the charge remains constant. Okay, now what is the equation? From the circuit, the total potential difference is sum of the potentials across the capacitors, that is V1 plus V2 plus V3. Now what is V from this equation? Which implies V is equal to Q upon C. So V1 will be Q divided by C1, that is Q divided by C1 plus Q divided by C2 plus Q divided by C3. Why? The charges are same in series and only the potential difference is different across each capacitance, right? That is equal to Q is common, okay, 1 upon C1 plus 1 upon C2 plus 1 upon C3. What is this? This is potential. So V divided by, bring this Q down, V by Q. Q by V is capacitance. Q by V is capacitance. Then V by Q will be reciprocal of capacitance, that is 1 upon C, which is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the formula when you connect the capacitors in series. Don't you think it is just opposite to that of resistance? Yes, it is opposite to that of connecting resistors in series and parallel. Now our last exercise is here. We are going to connect the capacitors in parallel. Okay. Now how do we connect it? Let us take three capacitors. Fine. Capacitance 1, second capacitance, third capacitance. Capacitors are two parallel lines. Remember that. A cell is one long line and one short line. Yes, this is point A and this is point B. C1, C2, C3. Now what is the potential difference we are connecting? Is V. V is the potential difference. Remember, when capacitors are connected in parallel, the potential difference will remain constant. Just like in series, in the resistors, you are finding that potential difference is constant. So here also, when they are connected in parallel, C1 is V, C2 is V, and C3 is V. Then what is going to change? We said before, two quantities are involved. C is equal to definition Q upon V. Now V is constant. So what is going to change? Capacitors are different. So charges are going to be different. Right? So on this plus Q1 plus Q2. Let me write C1 here. Right? And C2 here. Plus Q minus Q1 plus Q2 minus Q2 plus Q3 minus Q3. Let me write C3 here. Okay? Q1 plus Q1 minus Q1 plus Q2 minus Q2 plus Q3 minus Q3. Now we have got the three values here. Fine. Now we need to just make substitution. Fine. Now what is going to change and what is not going to change? Let us watch carefully. We need to calculate here Q. The total charge which is going through here is Q. So the main formula is Q is equal to Q1 plus Q2 plus Q3. Now what is Q from this equation? CV. Sir CV Raman. CV. Capacitance into the potential difference. So Q1 is C1 V1 plus C2 V2 plus C3 V3. Is it correct? No. C1 V, C2 V, C3 V. Why? Because potential difference is constant. That is equal to V is constant. C1 plus C2 plus C3. Close the bracket. So Q and Q upon V. What is Q upon V? Capacitance, equivalent capacitance. So C is equal to C1 plus C2 plus C3. So this is the formula when you connect the capacitances in parallel. So what does it mean? The C means C equivalent capacitance. If I remove all the three capacitors away, if I remove all of them and put it as a single capacitor, right, like this, then if this is the point B and if this is the point A and connected to a potential difference V, then you will find that the capacitance, equivalent capacitance will be C. It's very simple. I'll do one problem for you. Okay, let me take 1 picofarad, 2 picofarad and 3 picofarad. Right? Now very simple. C1 plus C2 plus C3. 1 plus 2 plus 3. That is equivalent capacitance is 6 picofarad. But if I connect them in series, it will become 1 upon C1 plus 1 upon C2 plus 1 upon C3. In the next video, we will continue with more topic on capacitors. Thank you.